Hello, my awesome students. In this video, we will be focusing on how to fill in that 16 box punnett square that is on this slide, or that you had to draw onto your poster, or that you had to include in the document for your essay. The thing that a lot of my students found confusing was that I did not just want you to go and put in a cross of two heterozygous parents that looked like one capital and one lowercase for each. What I wanted from you this time was to go and randomize what alleles those parents had. So, in order to do this, bear with me for a second. I am going to set up a little space to do my explaining. You might want a piece of scratch paper so you don't have to do this in slides, but or directly onto your poster. But the parents that I'm going to be generating are going to need 4 different alleles, and I'm going to randomize them using the dice roller. So dice roller, or actually you could even just use the coin flip. Coin flip. There we go. I'm going to use heads for dominant and tails for recessive each time. So looks like the first one I got was tails. Oops, that is where I'm putting these videos. There we go. Tails is for recessive. So for my first trait, the one about wings, I'm going to go and put a recessive allele in. And I'm going to flip again. Oh, recessive again. All right, dominant and recessive. All right. So there's my first parent. The second parent I'm going to do is, let's find out. Dominant, dominant, dominant. Uh-oh. Well, that's going to make this punnett square easy peasy. Dominant, 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 dominant. There you go. So this is a little bit different because technically now I don't really need a 16 square punnett square, as there's only one option that this parent can give, but I'm still going to fill one out in here just so that you can see why we don't need it anymore. The math part is going to be very, very easy. So let's start with WW, with the lowercase one. So all of the possible alleles that the first parent can give are lowercase w, right? They're all recessive. This parent cannot give any dominant alleles. However, for the second gene we're looking at, there's dominant and recessive, and it's a 50-50 shot. So I'm going to make half of them dominant and half of them recessive. Now I'm going to try the other parent. So this other parent can literally only make one combination. It can only give dominant capital W, and it can only give the dominant is capital G. So all of them should be the same. All right. Now, just like with the other punnett square we've done, you're meeting like a multiplication chart, but this time you're putting in 4 letters instead, and we'll do it like this. So W, and then the W from over here, and capital G, and capital G. There we go. I wrote the W's before the G's, and I wrote the capitals before the lower cases, and you're going to keep your same system every time. You probably have different letters that aren't W and G, but it should work similarly. Now I have the same thing again because I have the same combination of letters. Oops. W, W, G, G. All right, then you just go through and you fill out your whole box. Oh, wrong one. I was scared for a second there. Oh, it won't let me pause it? Okay, I guess you gotta watch me fill out the whole box. I'll be fast. Oop. There we go. And we are done. So finally, I need to do the calculations, and I'm going to go and grab the template for this as well because it will make your life easier. It will make my life easier while I'm doing this. There we go. And what kind of cross did we have? We had... There we go. So blank out of 16 have this and this trait. This is what percentage? All right. So we're going to look and see how many of them have each combination of traits. So the first I'm going to look at is 2 wings and are green. And I'm going to look at 2 wings and are blue. And then I'm going to look at 4 wings and are green. Then 4 wings and are blue. So I have to find out how many out of 16 have 2 wings and are green. You are filling in your own traits, obviously. Once again, you probably didn't do the same traits as me. So I'm going to look at this and I'm going to say how many of these would have 2 wings and be green. Well, 2 wings is my dominant trait and green is my dominant trait. And guess what? Every single one of these has 2 wings and is green because in my example, I had all dominant letters along one side, and so it was impossible to get away with any other kind of combination that showed the recessive trait. So 16 out of 16 of these are showing the doubly dominant traits. And 0 out of 16 show anything else, which is why I said earlier that that would make my math easy. In order to find the percentages, though, just in case you don't have the easy math like me of saying it's 100%, all you do is you divide your first number by your second number to find the percentage. So I divide 16 by 16, and that's 1. So I became 100%. If I had divided a smaller number by 16, it would have given me a decimal. You use that decimal to figure out the percentage. So, for instance, if like half of them that was bad math. If half of them 8 out of 16, 8 divided by 16, it gives me 0.5, which is like saying 50%. Or if I had done 2 divided by 16, it would have given me 0.125, which would be 12.5%. And so whatever you get, you multiply by 100 to bring it to a percent. See, 12.5%. but that is how you do the math for that. Once again, it's whatever number of boxes contain that combination. So if 9 of the boxes out of 16 contain that combination, then 9 divided by 16 is the math you would do. Oh, it looks like that's 56.25%. But for me, 0 out of 16 is 0%. So my math is super easy for this Punnett square. And that's how you do that. The only step I have left on this is to answer these two questions. What is a gene and how DNA is passed down? Once you've done all of that, make your poster or make your slides pretty, because creativity is important and these should be nice to look at while you're presenting. If you've got all the information and your slides are nice and pretty and they've got a little bit of creativity in there, like a picture to show us what your creature looks like, then you are all done. Good work.